In our video lesson today, we are going to learn how to add and subtract numbers in their standard form. In our last class, I taught you how to write numbers in standard forms. So now, carrying out basic operations on them, it's important for you to know how to do that. We will learn addition and subtraction of numbers in standard form first. Then of course, in our next class, we'll treat multiplication and division of numbers in their standard form. How do we add and subtract numbers in their standard form? It's a simple one, all right? The knowledge is not too different from what you have learned already under the basic operation, addition and subtraction. The only thing here is that for you to add numbers in their standard form or subtract them, their powers of 10 must be the same. That is to say that the numbers must have the same powers of 10. Let's assume that 1 is maybe the power of 10 in 1 is minus 5. Then the other number, the power of 10 there, should also be minus 5. That is the condition under which you can add or subtract the numbers in standard form. This simply means that if the numbers, their powers of 10 are not the same, then you cannot add them directly. You have to do something to make their powers equal. And what you have to do is simply about point movement. That's the decimal point movement. You have to move the point correctly so as to be able to make their powers of 10 equal. In our last class, I've taught you already how to move points and what will happen to the power of 10. If you're moving to the right, you move point, decimal point to the right, you subtract from power of 10. And if you're moving the decimal point to the left, you add to the power of what? 10. So that knowledge will help you to be able to make the powers of 10 to be the same. And once you do that, the remaining is just theory. Just carry out the addition of the numbers. Then of course, pick one of the 10 raised to the given power you have there. It's alright, please, like I have here, note the knowledge of decimal point movement, the knowledge of addition, and the knowledge of subtraction are required here. We have our very first question here. Let us solve and then you see how this is being done. Like I said, it's a simple thing. Add 24.2 times 10 raised to the power 3 and 6.01 times 10 raised to the power 2. So I'm going to have this plus 6.01 times 10 raised to the power 2. If you look at these two numbers you are adding, their powers, the powers of 10 there, are different. Because the powers of 10 are different, I will decide, okay, in which power am I going to solve this problem? Will I decide to solve it in 10 raised to the power 3? Or do I want to solve it in 10 raised to the power 2? That will be my choice, okay? The same thing goes to you if you're solving a problem like this. The power of 10 to solve the question in will be your choice. When you get your final answer, if there is anything that still needs to be done to the power of 10, you do it from there. All you just need here is about decimal point movement correctly to give you what you want. Now, I would like to solve this problem in 10 raised to the power 2 power. I'd like to solve it using this 10 raised to the power 2. It means I need to find a way to reduce this power 3 of this 10 here, right? I have to find a way to reduce this 10 raised to the power 3 to 10 raised to the power 2. That is the only case where I can be able to add these two numbers. So I'm going to ask you, if I have 3 and I want that 3 to become 2, what do? Do I add 1 to it, or I will subtract 1 from it? That is very correct. You will minus 1 from 3 to get 2. But again, the question is this. Will I just wake up, then come to this place and subtract 1 from this 3? The answer is no. You need to do something, okay, that will help you subtract 1 from that power. This takes us to our last class. When do you do subtraction from power? When do you minus from power of 10? Is it when you move the points to the right or when you move the point to the left? What do you say? Fine. When you move the points to the right. That is what will allow you to subtract from the power. Therefore, for this problem, I will move the point to the right once. So I'm going to do this equal to 24.2 times 10 raised to the power 3 plus 6.01 times 10 raised to the power 2. I'll come to this and then move the point once to the right. Something like this. So this is where the point is now, okay? Because I moved the point once to the right, I will minus 1 from power 3. So this is going to give me 242 points, then times 10 raised to power 2. No need of putting the point there because there is no digits here. Is that okay? So I'll now add 6.01 times 10 raised to power 2. Okay, so at this point, this is what I would do. I'll pick this number and then add them. 242 plus 6.01. I will add them and then pick only 1 times 10 raised to power 2. If you look at this, they have the same powers of 10 now. So just pick one of the times 10 raised to power 2. And this is going to give us 242 plus 6.01. This is what I am talking about. I'll now multiply it by, pick one of these 10 raised to power 2, since they are the same. So let us add up this and see. If you do your addition, 242 plus 6.01, you will get 248.01. If you want to use your place value method to solve it, okay? The choice is yours. Okay, so this is 242 plus 6.01, which will give us 248.01 times 10 raised to power 2. Now, this is meant to be my answer. This is supposed to be my answer. But there is something you need to know. When dealing with standard form, we prefer writing the answer in basic standard form. Where in the last class I told you that the whole number part is expected to be 1-digit number, a number from 1 to 9. Now if you look at this whole number part, this is 3-digit number, 248. So this answer we got is not in its basic standard form. So I'll have to do something to it to put it in its basic standard form. And from the knowledge of our last class, I think for this we need to move the point 2 times to the left. Let me do that. 1, 2. So that the point will appear here, and then these 2 will now be the whole number. And of course, once I do that, anyway, let me do the workings under here. Let me just show you. In other questions, I won't take my time to show you all of these. 248.01 times 10 raised to power 2. Then from here, I'll move the point 1 and 2. Because I moved it 2 times to the left, I'll come and add 2 to the power of 10 here. So this becomes 2.4801 times 10 raised to power 4. Let me conclude. 24.2 times 10 raised to power 3 plus 6.01 times 10 raised to power 2. My answer is going to give me 2.4801 times 10 raised to power 4. That's very good. I advise you to replay this video. Watch this very first question. I took my time to show you everything you need to know. We're going to look at our second question now. Our second question is a basic education certificate examination question, 2020. And the question reads, change 9 times 10 to the power of 3 plus 9 times 10 to the power of 2 to ordinary form. Remember I told you when we are studying standard form, we also talk about ordinary form, because we change from ordinary forms to standard forms. You can still change it back. If I give you something like 20.5 is an ordinary form of a number, but when it now becomes times 10 raised to the power something, it becomes standard form. So I decided to come up with this question, alright, so we can see how we can get our answer in ordinary form. But we still need to use the knowledge of standard form to add up this, even though there is another way one can decide to do it. The question here is 9 times 10 to the power 3 plus 9 times 10 raised to the power of 2. So this is what I'm going to do. I'll decide the power of 10 to solve this question. And once again, I would like to solve it in power 2. Or maybe let me go for power 3. Just because I want you to get the idea of this. You know, in question number 1, we had similar power 3, power 2. I solved in power 2 there. In this question, let me solve in power 3. Then at the end, whatever we get as our answer, we'll now decide on what to do to it, if that is not the answer directly here. Now, if I want to solve this question in power 3, it means I will increase this power 2 towards 3. So I will leave this number as it is and then focus on this. And how do I get that? This is equal to 9 times 10 raised to the power 3. I bring it down like that. Then plus, if I want this 2 to become 3, you are given the number 2. Do you add to it or you subtract from it to get 3? Good. You're going to add 1 to 2 to make that 2 3. If I am to increase this 2 to 3 now, which means I need to add 1 to it, it therefore means that I need point movement here. Remember I told you from our last class, if you are given a number standing alone, that number is 0.0. So if I have 9 like this, let's say times 10 raised to the power 2, this is the same as 9.0. Now I want this to become power 3, so I will have to move this point once to the left. And of course, if the point moves, you have something like this. The point will come here. This will become 0.9 times 10 raised to the power 2. 0.9, before this point there is nothing there, therefore it is 0. And once you move this point, you know you need to add 1 here. And this becomes 0.9 times 10 raised to the power 3. And of course, that is what I'm going to write here. 0.9 times 10 raised to the power 3. I told you I won't show all workings. I've done the rough work for you there to see. At this point, I will add this and this. 9 plus 0.9. Then I will pick one of the times 10 raised to the power 3 because it is common to them. It is the same for both numbers. If I add 9 plus 0.9, it's going to give me 9.9 times 10 raised to the power 3. Now, this is supposed to be my answer if I were to get the answer in standard form. But the question says we should get the answer in ordinary form. So we need to change this from standard form to ordinary form. We don't want to see this times 10 raised to any power again. So what do we do? It's simple. So I'll write to change to ordinary form. 10 raised to the power 3 is equal to 1000. If you take your mind back to our first secret foundation of mathematics, where we treated place values and standard values. For the place value 1000, the standard value is 1000. And I told you it is the same as 10 raised to the power 3. So this is 1000. Therefore, 9.9 times 10 raised to the power 3 is the same as 9.9 times 1000. And going by that, we can work out this. If you multiply 9.9 times 1000, what is going to happen? It's simple. You can use the point cancellation method, which we've treated from our last classes, previous classes. We've treated all of this from our previous classes. You remember on that division when you learned how to divide a number by a decimal number. So what do you do when you multiply something by a number that has 00 in it? This point, if it goes off, if this point goes off, it's going to cancel some zeros from here. The number of zeros is going to cancel depending on how many digits, decimal digits you have here. This is one decimal digit. So it's going to cancel 1 0 from here, and this point will go off. If it happens, this becomes 9. Of course, this goes off, like I said, it cancels one of these. So you have 99 times 100, which is simply 99, attach the 2 zeros. We've learned all of this from Secret Foundation of Mathematics in our last classes. So concluding, the question given to me, 9 times 10 raised to the power 3 plus 9 times 10 raised to the power 2 is equal to 9,900 in ordinary form. This is the ordinary form. Good. Coming over here, the correct answer is what? Option B. Option B is the correct answer. Let us move on to our next question, which is going to be based on subtraction. Question number 3 reads, subtract 36.2 times 10 raised to the power minus 4 from 0.0791. Are you worried about this question? It's a simple one, okay? Don't be scared of it. Just like we said, make sure that the numbers you're dealing with, they have the same powers of 10. This is an ordinary number. This is a number in standard form, but although not in basic standard form, okay? But it's generally in standard form because of this 10 raised to the power minus 4. Because my interest is for you to know how to solve addition and subtractions in standard form, I will change this ordinary form number to standard form. Then I will carry out the subtraction for you to see. The question given to me is to subtract this number from this. Mathematically, we write it as 0.0791 minus 36.2 times 10 raised to the power minus 4. I would like to solve this question in power minus 4. I'd like to solve it so that both numbers will have times 10 raised to the power minus 4. Now this one is already in times 10 raised to the power minus 4. But this is an ordinary number, which is the same as times 10 raised to the power 0. You know that, isn't it? Let me rewrite it for you to see. 0.0791. Now, because there is no times 10 raised to any power here, it means that this number is times 10 raised to the power 0. Last class I told you any number standing alone is times 10 raised to the power 0. Okay, so minus 36.2 times 10 raised to the power minus 4. Good, let us make this power to become power minus 4. And to do that, I'll have to move this point 4 times to the right. Is that clear? If you move this point 4 times to the right, let's say 1, 2, 3, and 4. The point comes here. This is going to be equal to 791 and then point. Now this is where the point would be. But no need of putting the point because after this there is no number here again, no digits. So I will simply write times 10 raised to the power. As I move to the point, I will subtract 4 from here, you know that. So that becomes 0 minus 4, giving us minus 4. Then minus 36.2 times 10 raised to the power minus 4. This is equal to 791 minus 36.2. This minus this. Then pick one of the 10 raised to the power minus 4, which is common to both of them. So you see, we handle this much similar to the way we solve addition of numbers in standard form. At this point, we'll do this subtraction quickly and see what we're going to get. You can decide to work it out here. 791, then subtract 36.2 from it. From our knowledge of subtraction, of course involving decimal numbers, you are expected to complete all empty place value. So this is 0.0. I'm just doing this to remind you of things you've learned under basic arithmetics. If you work on this, your answer will clearly be 8. This is 0. Borrow 1 from here to this, you get 10. Then 10 minus this is 4. Put your point here. This is 8. 8 minus 3 will give you 5. And of course, this is 7. So 754.8 will be our answer. 754.8. That is the result of this subtraction. 754.8 then times 10 raised to power minus 4. Now, if you look at this answer we got here, good. That is the answer we got. But generally, like I said, we always like our answer to be in basic standard form, where the whole number will just be 1 digit. So for that reason, I would like to move points to the left 2 times. But if your teacher wants you to leave your answer like this, it's still fine. Maybe in the option, if you see this answer and you don't see 7.548 times 10 raised to power minus 2, which I'm going to get as our final answer. If you see this answer, you can go for it. Okay, let us conclude. Moving our points, therefore, you're going to have that 0.0791 minus 36.2 times 10 raised to power minus 4. Our answer will now be, let me show you here, 1 and 2. Now that you move the points 2 times, you know what to do to the power. This eventually will become equal to 7.548 times 10 to power minus 4. You are going to add the 2 times you moved the points to the left. And if you work out this, minus 4 plus 2. Minus 4, you are owing 4. Plus 2, you have 2. Imagine you are owing somebody, let's say 4 oranges, and you are with 2 oranges. If you pay the person the 2 oranges you have, you will still be a debtor. You'll still be owing that person 2 more oranges. And because you are owing, it will be minus of the number you are owing. So minus 4 plus 2 is minus 2. 7.548 times 10 to the power of minus 2. This is my answer. I hope that is clear, right? Good. We shall take our last question now, number 4. And now, our last question, number 4. Evaluate 42 times 10 to the power of minus 7 minus 2.2 times 10 to the power of minus 6. Alright, now, like I told you, once you are given a problem on addition and subtraction of numbers in their standard form, you decide the power in which you want to solve the question. Now, if the numbers given to you, all of them are not in the same power, then simply change one of the number to the power of the other one by moving your points correctly. So here I am going to do same. For this question, I have decided I'm going to solve in power minus 6. That is my choice. You could decide to solve in power minus 7. At the end of everything, whatever you get in your final answer will now determine whether you will leave the answer like that or whether you still need to put it in basic standard form. Let's solve in power minus 6. So I have 42 times 10 to power minus 7, then minus 2.2 times 10 to power minus 6. So this is going to be equal to, since I want to solve in power minus 6, it means I need to do something to this power minus 7. If I give you minus 7, what would you do to it so that you would now get minus 6? Minus 7, you are owing somebody 7. You now want to owe the person 6. What would you do to that 7? If you are owing someone, let us say 7 oranges, and you now want the number of oranges you are owing to reduce to 6, it means you have to pay the person 1 orange. If you pay the person 1 orange, out of the 7 you are owing, then your debt will now reduce to 6 per se. But because you are still owing, it will be minus. Alright? So that you gave the person 1 orange means you added to the person. You did what? Added 1 to the person. So to make minus 7 become minus 6, you're going to add 1 to this minus 7. Question would then be, do you just wake up and add 1 to this minus 7 to get minus 6? And my answer is no. You need to do something that will allow you to add that 1 to minus 7. And what would you do? You move points. You know, this 42 is the same as 42 points, then times 10 to the power of minus 7, and then minus 2.2 times 10 to the power of minus 6. To add 1 to this minus 7, you move point once to the left. So here I'm going to move these points to this place. And so this becomes 4.2. Then times 10. Once you moved these points once to the left, you will now go and add 1 to that power. So minus 7 plus 1 would give you minus 6, the power that you want to work in. So this is 2.2 times 10 raised to the power minus 6. At this point, I will now have 4.2. I'll pick this number minus this 2.2. Alright, then in brackets. Then pick one of these times 10 raised to the power minus 6 because it is common. 10 raised to the power minus 6. 4.2 minus 2.2 would give you 2.0. And 2.0 is still the same as 2. Then times 10 raised to the power minus 6. We can conclude. Therefore, 42 times 10 raised to the power minus 7 minus 2.2 times 10 raised to the power minus 6, the answer is equal to 2 times 10 raised to the power minus 6. Does this make sense? So that is how we are done with addition and subtraction of numbers in standard form. Please take note, if you wanted to solve this thing in power minus 7, it means you will move this point, this one, once to the right, so that you minus 1 from these 6. If you have minus 6 minus 1, it will give you minus 7. And then you solve. By the end, you get your answer in times 10 raised to the power minus 7. Then, of course, you will check whether you need to do point movement in the final answer. If you do that, this will be 42 minus 22, which will be equal to 20. 20 times 10 raised to the power minus 7, which means you need to move your point once to the left to come between that 2 and 0 in 20. And if you move point to the left once, you add 1 to that power minus 7 to make it minus 6. You still get the same answer. Why not try that? Decide to solve in power minus 7. Then your final answer, put it in basic standard form. You still get this answer. Finally, I want to show you something. What if I said you should write this answer in ordinary form? Because that number is in standard form. If I say you should write it in ordinary form, let me just put note here. Alright. 2 times 10 raised to the power minus 6. In ordinary form is equal to, let me interpret it for you now. This raised to the power minus 6 means that we have 6 zeros before these 2. And so I'm going to put it as 0. After the first 0, you put points. 1, 2, 3, 4, 5. Altogether, we have 6 zeros now. Then you now write this 2. This is the ordinary form of this standard form. Ordinary form. Then let me write this one is standard form. I hope this makes sense, right? Come here. Look at this. This is 42 times 10 raised to the power minus 7. It means you have 7 zeros before this 42. So you write 0.6 other zeros, making it 7, then 4, 2. That's the ordinary form. We have done justice to this part of standard form. In our next class, as we round off standard form, I'll be teaching you how to carry out multiplication and division of standard form. I'm going to tell you something, just a little secret to prepare you ahead. I'll teach you just 2 laws of indices, because we need those 2 laws of indices to be able to solve problems on multiplication and division of numbers in standard form. Just 2 of the laws. We have multiplication law of indices and division law of indices. So prepare for that next class. I hope to see you. Take good care of yourself. Remember to take your quiz just below the lesson notes of this video lesson. 10 questions. Your target score, 10 over 10. To try yourself on how well you understand this addition and subtraction of numbers in their standard forms. If you have any question, you can rewatch the video lesson. Maybe your answer is there looking at you. But if you think you could not find your answer there, you know what to do. Just send your question right away to us and you would get a response.